Arina, and he is a chief biohacker and chairman of the board, as well as a renowned author at Biohacker Center. And he'll be speaking on exponential humanity in the age of biological machines. And this session will be hosted by Rico Pang.
Is Teemu on stage as well? Okay, great. Hi, everyone. I would like to introduce our next speaker, Teemu Arina, who is an iconic person in the biohacking space. He's an international recognized figure, pioneering the human ingredient in the future. He's also an awarded biohacker himself, best-selling author and award-winning keynote speakers. And he co-authored the book of defining the best-selling biohacker handbook for a series of optimizing health and performance with biological and technological tools. So without further ado, Teemu Arina, the stage is yours.
Wonderful. Thank you, Rico. So I'm delighted to be here. Let me share my screen. Here we go. And share. There we go. Hopefully it's visible. Yeah. So yeah, I will be diving into how to upgrade what it means to be human in the age of biological machines. So it's exponential times. That's why I have in the humans, I have the exponent mark as well. That's what we are going towards. We are basically looking at humanity accelerating in terms of the way how we use technology, but also biologically we will be evolving together with our technology as we go forward. And this was very exciting times for sure. Let me define biohacking, what that means. So biohacking is health and performance optimization based on lifestyle and medical and technological interventions, informed by science, bioinformatics, self-quantification, and guided self-experiments. So what we are basically looking at here is how can we optimize what it means to be human? Many people approach biohacking first from the point of view of like, how can I like have better cognitive performance or better attention, focus, and energy management when it comes to, you know, my body and my mind. But as people age and as they stress out and overwork, they get more interested in metabolic health, in nervous system health, in cardiovascular health, these aspects that are very key for helping you to live long and prosper. Now, if you live long enough, you probably get interested also in anti-aging and rejuvenation technologies and how to prevent disease as you age. But most people, when they get into biohacking, they get one of these sleep trackers. They might get a ring or a wristband or something like this, and they start to track their sleep and recovery and see how they're doing. Those are basically biometric data. And we have a lot of different type of data that we can get from the human body. So we're looking at as well on biomarkers. So that's your blood values and genetic data as well. So we can combine the different data points to better understand all these aspects of like, how can we really optimize your mind and body by using technology, nutrition, lifestyle modifications, and so on. I wrote a book called The Biohacker's Handbook. It's available at biohackercenter.com. I have the link in the end. But it's a very big book. It's about 500 pages, and it goes deep into optimizing what it means to be human. I wrote it together with a nutrition specialist called Jaakko Halmetto and a doctor, holistic functional doctor called Olli Sovijärvi, who is very famous in this part of the world where I am. I'm a technologist, so I'm looking at these things from the technology angle, but I do understand the biochemistry as well. And in this book, we go through the kind of 5 key pillars of your life: sleep, exercise, nutrition, mind, and work, and how those can be understood as systems and how those systems can be optimized for better health and well-being. Basically, the human body is kind of a biological computer. And if you look at sleep in your brain, we can see in the EEG, the brain waves, we can see different changes as you go to sleep. So we can understand the depth and deepness of your sleep, as well as recovery that happens, memory consolidation, and so on. Once you understand that, you can also start to like look at things, how you can use to optimize your sleep. in terms of nutrition, we might look at your digestion, we might look at nutrient absorption, we might look at genetics, like how your body processes different molecules through different biochemical pathways, etc. So all of these can be understood through the lens of systems. And once you understand the systems, then we can optimize them. Now, I'm organizing a conference called the Biohacker Summit in Helsinki next week, 3 and 4 of June. By the way, it's also available online. So if you are not able to travel to Helsinki at this time to join, 800 other people interested in optimizing their health, you can also follow this online. We are focusing specifically on this aging aspect and reversing aging and how to extend the health span. Now, if we look at age in general, it took us as humanity, it took us a long time to reach 1 billion people on this planet. As we entered the Industrial Revolution, our technological capability went off the roof. With the technological capability, also our understanding of medicine improved. Hygiene was a big thing during war times, for example, that saved lives. Our discovery of bacteria as well as antibiotics, certain vaccines later on, but a lot of different interventions that help us to make sure that you're not dying in an infectious disease, but you're more likely to die in something called a degenerative disease. So something that is related to aging. Those are things like diabetes, cardiovascular disease, cancers, etc. Actually, for someone my age, I just turned 40. Someone my age or lower, the highest likelihood of you dying is actually getting into a traumatic accident, like in a car accident or something like this. So I recommend you to use a seatbelt. But in a sense, like what we have seen is doubling human life expectancy from 45 years old on average to over 80, 85, for example, in my country, in Finland. And that is because of our discoveries in medicine and healthcare, and also the improvements of logistics, of food, products, etc., hygiene, so many things. And we can expect this to continue. If we take all the technologies that we have today, we might be able to push human average lifespan to, let's say, 90, maybe a little bit more. But I believe that in our lifetime, already the person who will live 150 years old has been born. It might be you. So if you live long enough, you might be able to escape the kind of aging trajectory. So with all these regenerative medicines, we might be able to reverse conditions that are related to aging, that are causative and related to the fact that we at maximum will live like 120 years old if you are lucky enough to become a centenarian. But most of us are not as lucky. So 27% of world population lives with multiple chronic conditions. If you live to more than 65 years old, 64% will have 2 or more chronic conditions overlapping. If you look at the leading causes of early death and disability, we have heart disease, we have strokes, we have cancers, all of that, respiratory diseases. But even the workplace, we have low back pain, we have spinal cord issues, we have all kinds of things, headaches, but mainly like our bodies are deteriorating as we age. It's not necessarily an external force like a bacterial virus that will take you. With medical treatments, we have been able to double lifespan expectancy from 45 to 85. With good lifestyle choices like food choices, exercise, supplementation, good social support, you might be able to live to become a centenarian. I believe that with biohacking technologies, we will be able to push that even further, 100, 150, potentially in the next few decades. One of the key aspects here is that current healthcare system is actually health in hindsight. It is not healthcare, it is sick care. It is focused on sickness, it's focused on diagnosing sickness, it's focused on therapies and sickness. In a sick care system, you are not diagnosing things that might break out in 20, 30 years of your life because you don't have any symptoms yet. But with preventive medicine or predictive medicine or predictive healthcare, we will be able to use data to predict that, like, these genetic pathways, this diet, these lifestyle choices, this stress load that you're under, whatever, this health condition that is like slowly creeping onto you. Maybe it's hormonal, maybe it's some kind of cancer, whatever is going to take you in 20, 30 years time. But we are not treating that bug in a sense until it's too late. And when you have symptoms, it's often already too late, like getting a diabetes as an adult. It's very hard to reverse. It's possible, but it's very hard. So you better start, today. And with data, we can access and we can personalize that to the individual and figure out from population studies and your personal data sets, we can figure out that these patterns of behavior might be leading to your earlier demise than you believe. And by doing a few modifications, we might be able to reverse some of those aspects. And many of those aspects are actually related to lifestyle, the way how you deal with your environment, how you deal with exercise, with diets, with sleep, stress management, and so on. Now, the human biological computer, and the blueprint is, by the way, here behind. It's different biomedical pathways that we know that exist in the human body. Is very much a computer. So if you start from the lower levels, you start from DNA, you go to protein synthesis, you go to different pathways, you go into the organ systems, and you go into the organism itself. What you see is different signals. It could be electric signals in the nervous system. It can be biochemical messengers or packages. Just like between computers, your body is sending different types of information around, and it's acting on it through your synapses and through your nervous system and lymphatic system and cardiovascular system, etc. We can map this out and we can understand what's going on. And we can understand also how that relates to the environment. So we can look at how it connects to the wider ecology. We can look at the bacteria in your gut. It's called the microbiome. We can look at it on your skin. We see the interaction because in the end, who is you is a connection of different intelligences. There's actually more microorganisms in your body than there are your own individual cells. They're just way more microscopic. And those guys are also affecting the homeostasis or the balance in your body. And sometimes they are supporting your immunity. Sometimes it is actually hindering your immunity. So it's good to understand like how this diversity of different species living in you are connected to you. And we are not isolated from our environment. I believe that the future of health is in the data. So not just health records, not just genetic information, but data from your environment, from your behavior, from your phenotype, from your activities. This can be mined. It can be understood through machine learning. We can look at the metabolome and the metabolomics, and we can figure out like how to optimize health. Now, bioinformatics will be for health, what the microscope was for biology or what the telescope was for astronomy. I believe so. Health is, in my experience, to be in balance. Imbalance leads to disease. Your body has all these homeostatic systems that are trying to keep the balance. And we can understand those things, for example, in terms of your blood work. Now, here's some of those like biomarkers from my own experience from the last 10 years or so. I've been measuring on a regular basis, like different aspects, like over 100 biomarkers. So here's a little snapshot, some highlights on it. I've been able to reverse heart disease risk, diabetes risk, organ failure risk, and the risk of becoming an old man, just hormonally. When labs do these tests, they look at reference range. So when you're on green, you're kind of within reference range. But when you're within green, it doesn't mean it's optimal. For example, with this ratio, you want to be as low as possible. With hemoglobin A1C, you definitely want that to be as low as possible. With hormones, you don't want it to be as low as possible. You want it to be as high as possible, but not too high, because that is linked to cancers. So you want to be a healthy human. And at the age of 30, when I started doing these things, I looked like I'm a 45-year-old man. Now at 40, I look like I'm a 25-year-old man. So a lot of these changes are not random. They are the result of systematic health and performance optimization. And we can start from, human genetics. We can look at the human genome, the sequencing, and the cost of it has gone down dramatically. From 10 years ago, it was 10 million. Now it's like less than $1,000. You can get like a pretty good picture of what you're made out of. From that, you can understand your aging as well. When we look at epigenetic change from the whole human genome. When I did this test, I was 2 years younger than what I'm chronologically. And there is different tests that you can do on telomere length, on glycation, biomarkers, a lot of things. On different measures, I'm somewhere between 25 and 35, even though I'm 40. Now, from genetics, you can also optimize things like nutrition. It's called nutrigenomics. So applying genetics on nutrition. I understand, for example, that I have higher risk of getting celiac disease as an adult if I would consume wheat products a lot. Like I don't have like gluten intolerance, so I don't have celiac disease. I don't have like clear allergic reactions, but I have the genetic makeup that would trigger potentially that condition later in life. So I want to silence those genes as much as possible by not triggering them, by not pressing those buttons. Once you know what buttons you are made out of, you know which buttons to press and in which way, and that is often linked to lifestyle. Now we can gather a lot of biometric information and biosignals also from the human body. Peter Drucker, who was a management theorist, said that what gets measured gets managed. That's definitely true for companies. It's also true for you. Do you know what your black box, your body is actually made out of, like how you optimize it based on data? I do nowadays because of quantified self. So I've been tracking, a lot of different data points, from diet to activity to biomarkers to brain activity to sleep quality and mood and many other things, and labs. And there are all these sensors that we can use, not just pedometrics that give you like steps, but now we have intelligence, artificial intelligence built in as software that starts to be your coach. Basically, you have like an Olympic athlete coach in your pocket that knows you better than you do. And based on the data that we are receiving, we can read between the lines even more than ever before. And these are way cheaper and way more accurate than they were, let's say, 5 or 10 years ago. And they are becoming cheaper and cheaper and more accurate and better with how you charge them or how you fuel them. Maybe in the future it's fully kinetic, so kinetic energy, you don't need a battery. But in the end, we will be able to gather data in such a way that we become not just blood donors, but data donors. We donate our data. And many people maybe have, a sleep tracker like the Oura Ring, which is a Finnish invention for tracking their sleep and activity and understanding the recovery. So this device has so many different things, from heart rate monitor to temperature monitor to understanding the sleep components. And from that, it can devise a lot of interesting data points. For example, understanding in your chronotype, like what time of the day you should go to sleep. Like not everyone is actually an early riser in the morning or a night owl. Like this is a genetic thing, but it's also a behavioral thing. But we can see from the sleep data what would be optimal for you, when to wake up, when to go to sleep. We can see from this data when you're actually recovered. Even if you slept 8 hours, it doesn't mean you fully recovered, because what should happen to your heart rate? It should start coming up a little bit in the morning because of cortisol release. And it should look like a hammock. And then there's the heart rate variability. You should see amplitude increasing in your heart rate variability, which is an indicator of stress and recovery. Now, if we look forward, just a few years forward, the ideas of where we are going as exponential humanity. With exponential technologies, we see that exponential change is such that in the next few years, the change is going to be as much as in the last 10 years or a few decades. I believe so, with artificial intelligence, mixed reality, virtual reality, synthetic biology, all of these. Many science fiction authors have seen these things coming, like Werner Winch in 2006 in the book rainbow's end, was describing ubiquitous high band networking, where you are earning small income through informal part-time work. Let's call that crypto or something like this, proof of work, Internet of Things. People have like some kind of headgear or eye gear, which they can use to overlay information on the retina, on what they see. We see everyone is connected to everyone else, and that causes all kinds of problems. We have people on metaverse, so avatars meeting in a virtual point. We have augmented reality applications. We have artificial intelligence acting as a digital assistant. We have understanding of anti-aging and how to reverse aging capabilities. And we have home delivery of goods. Like none of this existed like 2006. This guy was able to predict it. And now we see that it's very much becoming true. Another book from '85, Bruce Sterling, Schismatrix Plus, describes a future where we don't have political parties like the left and the right, but we have people who modify themselves through biology and people who modify themselves through technology. And these are the guys who are basically deciding the future of humanity. We are moving from evolution by natural selection to evolution by intelligent design, where we become part of influencing where we are going as humanity. We see anti-aging genetic engineering emerging. So we might be able to reverse a lot of genetic conditions or aging conditions through gene therapies. We see regenerative medicine. We can regrow tissues, 3D print organs. We can fix bugs. We can use stem cells. We see technological extensions of humans, cyborg attachments on humans. Like think of Elon Musk and his Neuralink technology, connecting humans to computers. We see like the most extreme treatments. Like if medicine can save you, like you have diabetes and Alzheimer's, and we don't know what to do, we're gonna freeze you up. We're gonna freeze you up, slow down time, and we're gonna reanimate you once medicine has developed, once science and technology has developed far enough, so that we can bring you back to life and we can fix that problem before your body breaks down. And there is thousands of people or tens of thousands of people already around the world who have the capability of being cryopreserved if they die or are at the risk of dying. And then we have, of course, artificial intelligence, which might be able to replicate you in a digital realm, or you can't really like say like pick a difference between a human and a machine online. So we might have AI that is passing the Turing test, so you can recognize if it's a machine or not. Now, I see that AI is mainly supporting human activity today, and together with machines, we are better. I don't see technology taking over. But if you die, technology can totally take you over. You can create like a digital immortality so that you keep on posting on social media, but it's an AI that just replicates what Teemu would probably post for the next few decades for the amusement of his family, even though he's dead. His ideas or his nervous system as a learned system might be able to continue learning and continue growing. I believe that the biggest transition is now from industrial revolution in terms of automation and assembly lines to augmenting humans. We will be augmenting human capabilities in so many different ways. And we see this as the fifth industrial revolution. So we move from mechanized production and mass production to computerization and optimized supply chains and all that, to the current one, which is the technological convergence of AI, big data, robotics, different user interfaces. Like think of self-driving cars, for example, or a smartphone, like how that converges all these different technological capabilities, software, hardware into one. The next one is the convergence between technology and biology. So the machine is converging with your body. It's already on your skin as a smartwatch. It's already on your skin as a smart ring. next it's going to be in your body. You know, it's a freaking nanobot in your nervous system or in your lymphatic system, tapping cancer cells or supporting your cognitive faculties. Synthetic biology is a very interesting area. Joy Ito, one of the directors of MIT Media Lab, previous one, he said that biology is the next digital. Bio is the next digital. And that's why I'm in the field of biohacking myself. I think it's the next thing. I'm also kind of interested to look beyond. So if we are optimizing ourselves, the question is like, for what reason? Of course, for resilience and becoming, harder to kill, but also like to evolve as a human being. And that's why we are working on a next book called The Resilient Being, which is about mastering your biology for resilience, immunity, and longevity. If you're interested in any of this stuff, I recommend you highly to go to biohackersummit.com, sign up for our online stream. It's going to go on next week. A lot of more intelligent people than me are going to talk about these topics in depth and give you practical tips. And if you can come to Helsinki, we still have a few tickets. If you can't, we can organize one in Amsterdam in October. But with that, thank you very much.
Thank you very much, Teemu. I think we have time for some questions here. So Kari, please bear with us. I think let's go through the questions quickly, Teemu, from the crowd. Teemu, the questions from Pamela. She's turning 32 soon. Do you think she's too old to be considered one of the population who will live to 150?
What did she say an age?
Yeah, she's 32 now.
32. Okay. I think she has a really good likelihood of escaping the aging trajectory, because there are 10 hallmarks of aging. There's actually 9, but they're adding a 10th one. So those are the mechanisms of aging, and we have a pretty good idea of many of them. And I think we will figure them out in the next 5-10 years. And once you turn like 45, from there on, it's downhill. From 40, it's already a downhill for many, but from 45 onwards, it's a downhill. So you have a decade still ahead of you of technological progress that can help you to deal with what comes after you turn 45. And then, like, if you are already 50 or something like this, man, I don't know if we can help you, but hopefully we can at least put you as a brain in a jar or something like that.
Great. I hope that answers your questions, Pamela. Another questions, do you have top 3 supplement recommendation that may gain momentum over the next 5 to 10 years, like prebiotics or nicotinamide or mononucleotide NMN sort of things? Yeah.
So NAD plus, so nicotinamide riboside, is a molecule that is very essential for energy production in the human body and in cells particularly. And as you age, you lose mitochondria and your NAD production goes down, and that slows down recovery and it speeds up aging, and it has all these different things. And maybe we will have molecular ways like taking NAD supplements to mitigate some of that damage. But the human body is a homeostatic system, and many of these anti-aging treatments turn out to be, if you overdo them, can also be cancer promoting. This is something that is very good to keep in mind, like all these hormonal therapies and everything. Like it's a sweet spot that you want to kind of go for. So more is not better with most things, just enough so that you can kind of keep your body functioning properly. Like even melatonin, as you age, your body is producing less melatonin. Microdosing a little bit of melatonin is probably a good idea. But if you're a young, healthy adult, I don't think you get much benefit of taking melatonin specifically, although it helps with recovery and it's actually a key component in the immune system as well. It's not just a sleep hormone. So what I'm really excited about myself in the end is a whole food diet, so that you get, nutrient dense foods, and then you supplement on top of that. So you measure and you figure out where your deficiencies are and you fix those, so that you oil the system in a sense. Because if you are taking stimulants or uppers or like nootropics or whatever that's boost your performance, often you're burning the candle from both ends. Maybe it increases your heart rate. Maybe it's like, it's cancer promoting even. Like there's so many different things and aspects that you need to take into account. And I don't think there is a silver bullet to any of these, but I will die trying myself all of these things for sure.
Thank you very much, Teemu. There are more questions, but due to time constraints, we'll leave it to later. And I will, thank you again, Teemu, for joining us, and look forward to, you guys joining the Biohacking Summit in Helsinki in June 3rd and 4th. And the ticket links available in the DeepTech forum chatting. Thank you very much, Teemu. I will pass the stage back to the host, Karin, to bring back the next speakers. Thank you.